Using an appropriate row of Pascal's triangle, expand each of the following expressions. So the first thing we'll do is we will make our own Pascal's triangle. So we'll have 1, 1, and 1. That's the top part of the triangle. And then for each row, we start with a 1, and then we add the two numbers above to get that new number. So it's going to be 1, 2, then 1. Then it's going to be 1, and 1 plus 2 is 3. 3, 1, and then it's going to be 1, 1 plus 3 is 4, 3 plus 3 is 6, and then 4, and then 1. And then we'll leave it there because that's as far down the table as we'll need to go to expand to the powers of 3 and 4. So for our first one, in part A, we have x plus 2 to the power of 4, and we need to go down to the fifth row of the triangle to get the expansion coefficients. So x plus 2 to the power of 4, when expanded, will be equal to... Our first expansion coefficient is 1, and then we have x to the power of 4, and then 2 to the power of 0, and these powers here and here will always add up to 4. Then our next expansion coefficient is 4, and then we have x to the power of 1 less than 4 is 3, and 1 more than 0 is 1, so we have x to the power of 3, 2 to the power of 1. Then our next expansion coefficient from Pascal's triangle is the 6. And then we have x to the power of, and 1 less than 3 is 2. And then we have 2 to the power of 1 more than 1 is 2. Continuing along, our next expansion coefficient is 4 again. And this will be x to the power of 1 multiplied by 2 to the power of 3. And then finally, the last expansion coefficient is 1. And this will have x to the power of 0 and 2 to the power of 4. So if we go along, 2 to the power of 0 is just 1, and we have x to the power of 0, which is just 1. So we can now fully simplify this. So this is going to be equal to 1 times x to the power of 4 is just x to the power of 4. And for our next term, we have 4 times 2 is 8, and it's going to be x to the power of 3. And then we have plus, and it's 6 times 2 squared is 4, so it's plus 24, and then it's x to the power of 2. And then we have 4 and 2 to the power of 3 is 8, so that's going to be plus 32, and then it's just x. And then the last term is 2 to the power of 4, which gives plus 16. For part B, we're going to expand 2y plus 3 to the power of 3. So this time we go down to the fourth row of Pascal's triangle, and they will become the expansion coefficients. So when expanded, this is going to be equal to, and the first expansion coefficient is 1. And then we have 2y to the power of 3 and 3 to the power of 0. Then it will be plus 3 and 2y to the power of 1 less than 3 is 2 and 3 to the power of 1 more than 0 is 1. Plus our next expansion coefficient, which is 3. And then it becomes 2y to the power of 1 and 3 to the power of 2. And finally we have plus 1. And it will be 2y to the power of 0, 3 to the power of 3. So simplifying this down, we can see that 3 to the power of 0 is just 1, and 2y to the power of 0 is just 1. So this can be written as 1 times 2y to the power of 3, which is, you need to be careful, it's 2 to the power of 3 is 8, and then y to the power of 3 as well. And then plus 3 times 3 is 9, and then 2y to the power of 2 is 4. So it's 9 times 4 is plus 36 y to the power of 2. So you need to be careful with the index laws when you do this. And then we have plus, and it's 3 times 9 is 27, times 2 is 54, and then y. And then lastly, you have 1 times 1 times 3 to the power of 3, which is just plus 27. For our last example, we're going to just expand a minus b to the power of 4. So again, we go down to this fifth row of Pascal's triangle. And when we expand this, it's going to be equal to, and our expansion coefficients for this are 1, and then plus 4, plus 6, plus 4, and plus 1. And now we can go through and we can put in a to the power of 4, and then minus b to the power of 0, and then we're going to have a to the power of 1 less than 4 is 3, and minus b to the power of 1, and then a to the power of 2 minus b to the power of 2, and then a to the power of 1 minus b to the power of 3, and then a to the power of 0 minus b to the power of 4. So once again we can note that 0 and 4 adds up to 4, 3 and 1 adds up to the 4, 2 and 2 adds up to the 4, etc. So that's how we can keep our eye on what the powers should be during each stage of this expansion. So when we go through this and simplify, we find this is equal to, that's just 1 times a to the power of 4, so that's a to the power of 4, and that's because negative b to the power of 0 is just 1. Then we have 4, and this minus b to the power of 1 still has a negative in it, so this is going to be minus 4 a to the power of 3 times b. Then we have plus 6, and it's a squared b squared, because negative b all squared is positive b squared, so it's just 6a squared b squared. And then when we get to the power of 3, again this has a negative associated with it, so it's going to be minus 4, and it's going to be a to the power of 1 and b to the power of 3. And then for our last term, negative b to the power of 4 is just b to the power of 4, because if we have a negative multiplied by itself 4 times, it becomes positive, and a to the power of 0 is 1, so the final term is just plus b to the power of 4. So that's the expansion of a minus b to the power of 4. So on this slide, you can just see that when we use a calculator to expand these, we get all the same expressions, A, B, and C now highlighted as what we found on the previous slide, and they're repeated here as the answer for you.